Hi everyone, this video is on factoring binomials. A binomial means it's two terms, so we're only talking about two terms, not a trinomial like in previous lessons. Okay, square root, we've talked about square roots before, but a square root is one of two equal factors of a number. That's the symbol for square root, kind of looks like a division symbol, but with a check mark on the end. So here's some examples of perfect squares and their square roots. A perfect square is a number like 36. The square root of 36 is 6, because 6 times 6 is 36. The square root of x squared is x, because x times x is x squared. The square root of 64a squared would be 8a, because 8a times 8a is 64a squared. The square root of x to the fourth y to the fourth would be x squared y squared. Notice that with variables, the square root is half, the exponent is half of what the original exponent was. All right, 2b plus 3 squared, the square root would be 2b plus 3. All right, so we're going to talk about factoring the difference of two perfect squares. Okay, so this is two perfect squares. It's a difference, right? What does the word difference mean? It's a minus, and they have to be perfect squares, like 36 or 64 or 25. Those are perfect squares, so it has to be the difference of two perfect squares. Step one is we're going to set up two sets of parentheses, with one containing a plus in the middle and the other one a minus in the middle. Find the square root of the first perfect square and insert in the first positions of the parentheses. Find the square root of the second perfect square and insert it in the second term positions of the parentheses. And then you can always check it by FOIL. So there's our formula. A squared minus b squared equals a plus b times a minus b. The order doesn't matter. If you want to write a minus b times a plus b, that's fine. What is a property that tells us we could do that? Let's write the commutative property. Okay, here's our first two examples. Is it a difference in the middle? Yes, it's a difference, right? There's a minus in the middle. And are there perfect squares? Are both terms perfect squares? Yes. So we're going to start off with writing the parentheses, one with a plus, one with a minus. Doesn't matter which one you put first. Now we're going to find the square root of the first perfect square and insert it in the first term positions. What's the square root of 16x squared? That's right, 4x. You don't have to use the square root symbol if you don't want to. So 4x is going to go in the first positions of each set of parentheses. Now find the square root of the second perfect square. What's the square root of 9? That's right, it's 3. So now we're going to insert that in the second term position. So 3 and 3. And that's it. We're all done. 4x plus 3 times 4x minus 3. All right, try the next one. You can always pause and so you can work on it. All right, so is it a difference? Yes. Are both terms perfect squares? Yes. What's the square root of the first term? 7x. What's the square root of the second term? 9. So 9 will go in the second positions, and we're all done. 7x plus 9, 7x minus 9. All right. Difference of two squares? Yes. It's a minus? Yes. Set up our two parentheses, one with a plus, one with a minus. Square root of the first term. What times itself is 49? Yeah, 7. And then the exponents will always be half of what the term is. So if it's a to the fourth, it'll be a squared. And if it's b squared, it'll be b. So the square root would be 7a squared b. Because 7a squared b times 7a squared b is 49a to the fourth b squared. That goes in the first positions. What's the square root of 9? 3. That goes in the second positions. And then we're all done. All right, example 4. Is it a difference of two squares? It's not even a difference, right? Yeah, there's a plus sign in the middle. They are perfect squares, but it's not a minus in the middle, so there's nothing to do. There is no GCF. Nothing, not even a factor to factor up, no GCF. So it does not follow the pattern of the difference of two squares. The formula is only for the difference of two squares. There is no formula for the sum of two squares. So you don't even have to bother trying. The answer is not factorable. You can also write prime if you want. All right, 3x squared minus 75. A little bit different here. Is it a difference? Yes. Are they perfect squares? No. But we do not forget about our general steps to factoring. Number 1, make sure it's in order. Is it in order? Yes. So then we also go on to factoring out the GCF. What is our GCF? Right, 3. So factor out a 3. The 3 is written in front of the parentheses. And then divide each term by 3. What does that give us inside? X squared minus 25. All right, now we got to factor the x squared minus 25. That's the difference of two squares. That's x plus 5 times x minus 5. Is that our answer? Almost, just don't forget to bring down the GCF. So you do not want to forget that. All right, number 6. Is it in order? No, it's not. So make sure you put it in order. The negative 45x to the 5th should go first. Now we could factor out the GCF. What's our GCF? Let's see, 5, and then they have x's. We take the lowest exponent, so it'll be 5x to the 3rd. Oh, the first term is negative, so it'll be negative 5x to the 3rd. Now we could factor the difference of two squares. 9x squared minus 4. Okay, what is 9x squared minus 4 factor to? That'll be 3x and 3x and 2 and 2, so 3x plus 2 times 3x minus 2. And then don't forget to bring down the GCF. There's our final answer. All right, next example. Is it in order? Yes. Is there a GCF? Yes, our GCF is 5. So factor out the GCF. So that gives us x to the 4th minus 81. Are those two terms perfect squares? Yes. X to the 4th, the square root of x to the 4th is x squared. The square root of 81 is 9. So that's going to give us x squared plus 9 times x squared plus 9 times x squared minus 9. Don't forget to bring down the 5. Are we done? We're not done. If we look at those binomials, x squared plus 9 and x squared minus 9, the x squared minus 9 is also the difference of two squares. We could factor that again. How about the x squared plus 9? Because it's a plus sign, we can't do anything with it. So we're only going to factor the x squared minus 9. So what does that factor to? That'll be x plus 3 times x minus 3. Okay, and then the 5 and the x squared plus 9, we just have to bring it down. So that's our final answer. Factoring the sum and difference of two cubes. A cube root is a number whose cube is a given number. Here are some examples of perfect cubes and the cube root. 8 is a perfect cube. Its cube root is 2. 2 times 2 times 2 equals 8. X to the third is a perfect cube. Its cube root is x. X times x times x is x to the third. 64y to the third, its cube root is 4y. And 125x to the third, its cube root is 5x. Okay, so we're going to be factoring the sum and difference. So this time we can factor if there's a plus in the middle or a minus in the middle. We have two formulas. You should memorize these formulas. They'll come up often in math. So notice the patterns. In the first parentheses is just a and b. It's a binomial. The second parentheses is a trinomial. The first and last terms are both squares, and the middle term is a product. Notice that the first sign is the same sign as our given problem. If it's a plus in the middle, the first sign will be plus. If it's a minus in the middle, the first sign will be minus. In the trinomial, the first sign of the trinomial is always the opposite of whatever the first sign was. And the last sign is always positive. Okay, let's go on to the next page. Here's our procedure for factoring the sum or difference of two cubes. Step 1. Find the cube roots of the first and last term. Remember, this is a binomial, so there's only two terms, but we want to find the cube roots. It doesn't matter if it's a plus or a minus in the middle. We have two formulas, one for each. Step 2 is we will decide which formula will be used. If the sign between is a plus, then we're going to use the formula for the sum of two cubes. If between the cubes is a minus, we're going to use the difference of two cubes. Then we're going to replace a and b in the formula with the corresponding terms of the expression from step 1. So we're going to replace a and b with the cube roots. Right, so this phrase, soap, it may help you to memorize this formula. It stands for same, opposite, always positive. The first sign is the same, so look at our formulas. The first sign in the binomial is the same as the sum or difference of two cubes. The next sign is the opposite, and the last sign is always positive. Hopefully that will help to memorize these formulas. Okay, here's our first problem. X to the third minus 8. Here are our cube roots. The cube root of x to the third is x, and the cube root of 8 is 2. We're going to use the formula with the minus in the middle, so I rewrote it to the side. Again, if the original problem has a plus in the middle, we use the sum of two cubes. We use the formula for a cubed plus b cubed. Since it has a minus in the middle, we will use the formula for a cubed minus b cubed. All right, so it says a minus b, right? That's what we're just following the formula. A minus b. Well, what's our a? Our a is x, and our b is 2. So if it says a minus b, we're going to write x minus 2. Okay, now the first term in the trinomial, it says a squared. Our a is x, so what are we going to write down? X squared. Now our next sign, what's the sign in the formula? It says plus, so write down a plus. Then the middle term says a times b. A is x and b is 2. So what's x times 2? X times 2 is 2x. Okay, then look at the formula. It has a plus. So we're going to use these signs. You don't have to worry about the 8, is it positive or negative. These signs tell you what to write down. So it says plus, so we write down plus. And then it says b squared. Our b is 2, so we square 2, and that's going to be what goes in the last term of the trinomial. 2 squared is 4. That's it, we're all done. Just box it and move on to the next problem. Okay, number 9. So find our a and b. What's the cube root of 8x cubed and the cube root of 125? A is 2x and b is 5. Are we going to use the formula with a plus or with a minus? Well, with a plus, right? Okay, here's our formula. It says a plus b. So you're going to write down a plus b. You might want to write our parentheses first. So in the first parentheses, a plus b, that'll be 2x plus 5. Now we go to the trinomial. It says a squared. What does a squared mean? A squared means a times a. So that means it's 2x times 2x. What is 2x times 2x? That's 4x squared. So don't put 2x squared. Many people make that mistake and put 2x squared. A squared means to multiply a by itself. Since a is 2x, that means 2x times 2x. Okay, now the next sign. The formula says to put a minus. So we're going to write down a minus. Then it says a times b. So that's 2x times 5. What is 2x times 5? Right, that's 10x. Then a plus, because it says plus. B squared. B squared means b times b. So that's 5 times 5. which is 25. That's it. We're all done. All right, let's do another one. Example 10, 27x to the third minus 64y to the third. Are they perfect cubes? Yeah. What's our A and what's our B? Our A is 3x and our B is 4y. Is this a sum or difference of two cubes? It's a difference. So we're going to use that second formula, the bottom row, and use the formula for the difference of two cubes, a minus b times a squared plus ab plus b squared. All right, put it in our parentheses. It says a minus b. So what's a minus b? That'll be 3x minus 4y. Okay, then it says a squared. A is 3x. That means we got to multiply a by itself. Or multiply 3x by itself. What does that give you? 3x times 3x is 9x squared. Then a plus sign. Formula says plus. Then it says a times b. So 3x times 4y. That'll be 12xy. Then a plus sign. Then it says b squared. That means b times itself. 4y times 4y. Right, 16y squared. And we're done. All right, this is our last example. 3x to the third minus 375. Are they perfect cubes? No, they're not. Right? 3 isn't a perfect cube. Oh, but GCF. It's in order, so we got to go back to our basic steps to factoring. We got to factor out the GCF. Actually, we got to see if it's in order, and it is in order. So then we move on to the GCF. What is our GCF? Is it 3? Does 3 go into 375? It does. You can tell quite quickly there's a divisibility test for 3. If you add the 3, 7, and 5, that adds up to be 15. And 3 goes into 15, so therefore 3 will go into 375. Just got to divide it to see how many times. Okay, those are called divisibility rules. Anyways, okay, so let's factor out the GCF, which is 3. So that gives us x cubed minus, and then divide 375 by 3, and you should get 125. Now we could factor that binomial, which is the difference of two cubes. What's our a and what's our b? Our a is x, and our b is 5. We're going to use the formula that is for the difference of two cubes because it's a minus. It's already written on this page. So we could go ahead and do it. A minus b, x minus 5 times a squared. That'll be x squared. Plus ab, that'll be x times 5, which is 5x. Plus b squared, b is 5, so 5 squared would be 25. And then we're all done. Oh, don't forget to bring down that GCF. So don't forget to write down the 3 in front of the parentheses. That's our final answer. I'll see you here for the next video. Bye.